Well, hello friends. Welcome back to the program. Today we are going to take a look at some bugs reported by Luke, who has been fuzzing random stuff. And he's been fuzzing, for example, the PNG decoder implementation. So here we have some kind of assertion failure in the image decoder when loading some provided PNG. So that's cool. And then we have some other assertion failure while decoding another PNG. So I guess what we're going to do is we're just going to put these PNGs here into Serenity and see if we can reproduce the assertion. So I guess we'll start by just putting these in the build. So I'll call them by their bug numbers just to keep it a bit understandable. So this one was 3818. Okay, so we can immediately see here that they have some suspicious dimensions, negative height, both of these images. So I'm guessing that that's going to be a factor. We probably don't check for that. So let's see. So what happens if we just try to open one of these in Quick Show? Okay, so that fails indeed. And the other one, we get a slightly softer failure, so we fail, but keep running. So the app still starts. So this is kind of what we want to achieve. We just want the PNG loader to say, hey, this is not a valid PNG. We can't open this. So 3819, it seems, is able to handle this situation better. I wonder if that's something that we have fixed here in the meantime, because we might not be calling this code in the same way that we were 22 days ago. So let's start by taking a look at the 3818, I guess. So where are we asserting? It is footer should not be map failed in decode PNG bitmap. So it is trying to allocate a scan line, which is presumably very, very large, and then malloc calls mmap, which returns, well, it fails, basically. So, okay. So decode scan, no? Decode PNG bitmap. And then we are calling ensure capacity on something. So here, context scan lines, ensure capacity, context height. Yeah, so why do we allow these things to be negative in the first place? That is clearly a mistake. I think, let's see. So once we have parsed the headers, or the chunks, like once we have the chunks, then we have access to the width and height, of course, and I think at that point, actually we could do this even before decompressing. So if the context width less than 0 or context height less than 0, return false. Should be advanced to state at that point. Should set the state to error, I guess. So context state is PNG loading context state to error. Yeah, because it's just obviously never right to have negative width or height. So I don't know why we're using ints for these in the first place. Failed. And failed. That is much better. Okay. Well, that seems like a good fix to do by itself. So context width equal, where do we set this? Here. Okay, so when we're processing the header. I'm just thinking, should we fail sooner if we encounter a negative with their height? I think it might be okay to fail immediately when decoding the negative width or height, so we can just do that here. So these are unsigned 32-bit quantities, so I think if the width is greater than the numeric limits of I32 max, or iHeader height is greater than PNG has invalid geometry. Something like that. Yeah, I think this will be better, because then we'll just bail out of trying to process this image immediately when encountering the invalid width and height, instead of letting it continue all the way until we try to decode the pixels. I'm definitely a fan of like failing as early as possible instead of trying to do a bunch of stuff and then failing later. So we get rid of the stuff on 743. And instead we can, of course, we can assert a 0 by 0 image. Is that valid? I don't know. Do I have to do something like this? Yeah, I have to cast these because the formatting code sees that these are actually network ordered template types. Anyway. PNG has invalid geometry. See, there we go. That is very cool. Okay, and then it will just refuse in both cases to try to load them. So what was even the deal with this one? Previously it would fail an image decoder bitmap. So we would call bitmap on PNG image decoder plugin. And we had an assertion context bitmap here. So this one right here. So I think this assertion is sane. Because otherwise we should have bailed out here. And I think these assertions are sane now because we will fail in chunk decode if we have bad geometry. So I'm not sure why we were asserting here before, but nevertheless, this situation will not happen with this image anymore anyway, because this image will refuse to decode it. So I think we can close both of these issues. Lit graphics. Refuse to decode PNG images with unrepresentable. Wait, with outside I-32 bounds. Yeah. Fixes 3818, fixes 3819. Just failed the decode immediately when encountering an I-header chunk that width and or height outside larger than yeah. That seems pretty good. Now it makes me wonder if we have any other we have a GIF one and a PPM one. What's the GIF one? I guess we can take a look and see if this one still dies as well. We'll call that 3486.gif. Because why not? Maybe the PPM one will skip over right now. Okay, all right. So load GIF frame descriptors. GIF loader, line 390. So what is wrong with this image? Let's file 3486. Let's see what it says here. Negative or zero image size. Well, that is suspicious. So, like we could probably do the same thing here. Just fail immediately when we encounter a negative image size. So how does this thing actually report failure? Let's take a look. If you just return false, it will set it into an error state. That's really good. Okay. So if we just make load GIF frame descriptors fail, we can just fail right here. If value is less than, or wait. Maybe there's 0. It doesn't say here what the size is. Is that enough, I wonder? To just check for 0? Fuzzing is very nice. Like, I love that people are running fuzzers on our code. No, we're still failing. Okay, all right. Let's see where we're actually failing then. So adders to line, applications, quick show, this address, 395. Okay, so we are failing all the way up here, actually. So before we get to this code, why is that? Let's just print these out. Context data and context data size. Maybe the data size is 0. No, it's not, because then this would have failed. Unexpected application extension size. Sure. I feel like it's not quite telling me the truth about where we're failing. Or wait, maybe I'm just thinking about this the wrong way. Like, really, I should be looking at something else. What is the issue here? Let's just build this thing with debug symbols. Or rather, without optimizations, which we don't have to do that way. We can just do it here. If we turn off optimizations, then it tends to become a bit easier to see what's crashing where. Although maybe it didn't. Dang it. So I guess our stream goes out of scope and it has some error that was not handled. So stream. We handle errors here, handle it here, handle it here. And Where are we not handling errors? Well, we could just do this. That's probably sane anyway. So basically, before we return from this function, if the input stream had any error, like if we ran out of bytes, for example, then we should fail. Here we return false. Wait, what happens here? So we are iterating through the image descriptor, and we find this sentinel value, which tells us like what kind of chunk we're looking at. And we handled 21 and 2C. So okay, so I guess just because of the because it's a fuzzed GIF, it's going to have a malformed sentinel value, so it's not going to be 21 or 2C, so nor 3B, so we'll end up down here, and then we won't have handled stream error, so it's a little bit weird. So how does that go? Yeah. Okay, so that's the path that we're taking. So we read some value into Sentinel. Okay, so actually we can just do the checkup there. That is the tidy way of doing this. Yep, probably ran out of bytes. Okay. Yep. Okay, that's one more fix. So let's see. I think we can keep these two as well because they're not going to hurt us. Can refuse zero width or zero height images. Although, yeah, you know what? Let's not do that. Let's just leave that alone and take only the change required for this bug. So fixes 3486. Add missing stream error handling. If frame descriptor parse. Try to read a sentinel, but the stream is fresh out of data. We have to take care of the stream error and bail out right away, or we'll hit an assertion when exiting the function soon after. Yeah. Good. You know what? What was that ppm thing? since we're fixing things anyway. ppm loader. All right. So that's 3820.ppm. All right. Vector out of bounds read. That sounds about right. ppm loader. Okay, so what's going on here? Read image data. So we're loading a ppm, and we have color data at index. This one is saying the index is outside the bounds of color data. And where do we get index from? Index is just something that we increment here. And color data is a vector that we have here, okay? Okay, so it's like the colors in laid out in order. Okay, all right. So I guess that we are not, we have like some missing data or something. So how do we fail here? Read image data if that fails. Decode ppm if that fails. It really needs to set the context to a failed state at that point. Okay, so let's use a scope guard here to do that. So when we exit the scope, we'll set the state to error unless we disarm the scope guard. Yeah, because then we'll set it to decoded instead. That seems sensible. So if any of these things fail, and then read image data. Like if we don't have enough data here, then we just need to fail, essentially. So we can validate that up front, that if, before we allocate a bitmap actually, if context width times context height is not color data size. Then return false. So U16. Okay, all right. So that's fine. These we're not going to overflow here, so that seems fine. Yep. If we don't have enough entries in the color data vector to back this up. Oops. Yep, fail to open. Cool. I think we can pre-allocate the right number of bytes or entries in this thing. So we can do that. Because then there's no point in like dynamically allocating this thing if we know up front how many entries it's going to have. Yeah, that's good. Lib graphics. Fixes 3820. Fail ppm decode if there's not enough pixel data in the input. Yeah. Cool beans. All right, so we got our little fixes. So this means that it should also be safe now to open this directory in File Manager and allow it to create thumbnails for everything. I mean, it will just fail to create thumbnails because they're all broken, but we don't crash. Let me just see these guys down here. Cool. That's very cool. So I think this is going to be it for today's video. It was a little bit mixed things, but fixing fuzzer fuzzer found issues in our various image decoders, basically. So I think this is really awesome, and I hope to see more fuzzer bug reports, because we should have quite many bugs like this, I would expect. It's just the reality of writing binary format decoders in a language like C++, is that you have issues like this, and you need to use a fuzzer to flush them out. So super shout outs to Luke for reporting all of these bugs. Thank you very much, Luke. That's awesome. I hope that you keep fuzzing and reporting issues like this so that we can find and fix more of them. Okay, so that's going to be it for the video. So thank you very much for watching, for hanging out, and I hope that something about this interested you, and I will see you next time. Bye.